Okay, so now we are going to solve the problem removal game. There is a list of n numbers and two players who move alternatively. On each move, a player removes either the first or last number from the list, and the score increases by that number. Both players try to maximize their score. What is the maximum possible score of the first player when both the player play optimally? Okay, so what we are given? Okay, so we are given a list of numbers. Okay, and two players are playing a game. So what we will do, they will take alternate turns, and in each turn, they will either select the first element or the last element. Okay, so uh, the starting player can either choose four or three. Now, on basis of sorry, so now on basis of that, uh, of what choice first player has made, they would require the second player. The second player would have, if the first player would have chosen four, then the second player would have the choice 5 and 3. And if the first player had chosen 3, the second player would have choice 4 and 1. So, what is the maximum score they can achieve? Okay, so each player wants to maximize their score. So, now first you can think it that why not choose the best possible way? Means we have two options. Why don't take the maximum? That is 4. But this will fail because what if you choose this and the it unlocks some greater value for your opponent. Like in this case, only the greedy is failing. You can see that if we choose 4, then the second player would have 5 and 3 and he would take 5. Okay, so then you would have 1 and 3. So that way, it here, then the second player would have taken 5. Okay, now again you have option 1 and 3. You would have taken 3, that is 4 plus 1, and the second player would have 6. But what if here it was also 3? Okay, so now your greedy fails because you are first you are choosing 4 based on greedy. The next player will choose 5. Now you have 3 3. So it would be 7 and your opponent would have 8. What would you would have done? You would have either chosen 3. Okay. So now your player will have 4 or 3. Then whatever choice he makes, you would get to pick 5. So now the score would be reversed. It would be 7 and 8 and 7. Okay, so greedy fails. So what can we do? Okay. What we have to do? Suppose our starting is 0 and ending is n minus 1, the initial list. Now, what would be the, we have to find the maximum we can get from here. Okay. Now, there are two ways. Let us explore both the way. What if we have chosen 0? Okay. So then the answer would be a of 0 plus whatever answer we would have get from the remaining one. That is 1 to n minus 1. Okay. Here what we are storing, we will store what value the first player can get and what value the second player can get. Means first player means whoever is making the first turn in this range. Okay, and this 0 to n minus 2. Okay, now we would simply take the max of this both. Okay, now this will again get expanded. The second player can take A1. Okay, so you got my idea what I'm saying. So what you can store, TP of I of j can store two values. The first one can be maximum score player 1 can achieve. Player 1 means whoever is making the first turn. Okay. And the second is maximum value, max score player can get, second player can get. Max score player second can get. Okay. It is max score player 1 can achieve, and it is max score player 2 can achieve. So how we can now transit from one step to another? Suppose if we are at ij. Okay, so it would be whoever is making the first move. Okay, so let us consider two cases. What are the values we can get for the current option? We can either get, if we take ith element, then we can get dp of I plus j dot second. That is because this is our turn. So next, this is our turn. So the next value would be, this is our first turn. So in next turn, we would be second to get. So that's why dp of x would be whatever the, if we chose this element, then whatever for the next range, whatever would be the second value, that plus this element a or I. And the second one would be I to j plus 1 dot second plus this value, that is a of j, sorry, j minus 1. Okay, so this would be the high max value. Now, if x is greater than y, means the first choice is better than the second one. So then we would go with the first choice. So current dp of I comma j dot first would be equal to x. And what would be second? The second would be dp of, we have taken I plus 1 here. That is, we have taken the ith element here. So the second player would get dp of I plus 1 comma j dot first. Means next turn, there his turn would be the first turn. Okay, so this, or for else, what we can do, we can reverse it. It would be y and dp of I comma j dot second would be dp of I j minus 1 dot first. Okay, so this is how we can calculate it, and we can, at the last we can return dp of I comma j. Okay, so I hope you got it. So our recursion would be like this for I comma j. If I equal to j, then we would return the element itself. Actually, it is pair, then element itself and 0. Okay, so that is the case. Now the whole process, as I said, my bad. Okay, so I'm not writing it whole again. This whole process we would do here. Okay, here x would be a of x plus solve of, sorry, a of I plus solve of I plus 1 comma j dot second. Okay, and y would be a of j plus solve of I comma j minus 1 dot second. And now we can put the same condition if x and y, if x is greater than y, then we would return x and the second player would get solve of I plus 1 j dot first. Else we would return y and solve of I comma j minus 1 dot first. Okay, so this would be our code. Now we would be making repetitive calls, so we can memorize it. dp would be n comma n, because I can range from 0 to n and j can range from 0 to n. Okay, and if it is already found, then we can return that else before returning we can store it in dp value of I comma j. Okay, so this is how we will do it. Okay, so this was, let us try run also, because this question is a good one. So we would call for 0 comma 3. Okay, so for 0 comma 3, what would be the value we will get? We will call for 0 comma 2 and 1 comma 3. For this we would call for 0 comma 1 and 1 comma 2. For this we would call for 1 comma 2 and 2 comma 3. For this we would call 0 comma 0, 1 comma 1. Here also 1 comma 1, 2 comma 2, 1 comma 1, 2 comma 2, and 2 comma 2, and 3 comma 3. So this would return as 4 comma 0. This would return as 5 comma 0. Now this would return as 1 comma 0. and this would return as 3 comma 0. Okay, so whoever made the first turn as 0, this would be the answer. Now for this, we have chosen the first one, that is 5. So now this one will give us 5 comma 4, or this one would give us, here we have chosen the zeroth element, so it will give us 4 comma 5. Okay, so now we would select this because it is maximizing our answer. Okay, so now from 5 comma 4, so now here we have chosen the second one. Okay, the second element is 1. So here we will get, from this we will get 5 comma, and what would be the answer for second? 5 comma 5. And here we would have gotten, if we have chosen the zeroth element, then we have to calculate this also. So I hope you get it how the calls are making. So at final, we would be getting the max answer for first and second. Okay, so this would be now for the tabular approach. You guys would be thinking that how we can start from where we would, how the loops will work. Like if we go from 0 to L, that is the left and right limit. Okay, and if we go from 0 to 1. So for seeing in tabular how the calculations would be made, okay, just write down what would be the value for I comma j. It will depend on I plus 1, and it would depend on j minus 1. Okay, so ith loop, we can go from 0 to, we can go from L to 0, because for the current I, we would have required I plus 1. Okay, so if first we will calculate L, that is our left limit. Okay, so now when we would be calculating L minus 1, we have already calculated this. And for the right one, that is for the jth limit, what we can do, we can go from 0 to R, because when we are calculating for j, we are going in decreasing order. So for current j, we would have required j minus 1. And for current I, we would have required I plus 1. So we will loop for I. So we will loop L to 0, and we will loop for R L to N. Yes, because ending point, this can never, we can't start from 0, we can't start from 1 and end at 0. Okay, so that is not possible. We can't choose L as 1 and R as 0. It would always be start from L. So it can go 1, 1, 1, 2, 1, 3. It's possible. 1, 0 is never possible. So that's why. So this is how the looping will work. We will go from I L to 0, I from n minus 1 to 0, and here we will go from j equal to I to n. Okay, and we will do the same steps as we did earlier. You can see that in the code. Okay, so let's code. Okay, so Here we would be taking long run because the 10 e power 9 into n can become very big. So we will do everything in long, so it will save us from integer overflow. So what would be a dp of I comma j would store? It would store the max score player starting max score or both the players if starting was I and ending was j. Okay, so it will store max scores of both players if starting was I and ending was j index. The first value will store for the player who starts first in this term, who starts first, and the second will be remaining player. Okay, so this would be a DP. Let's initialize our DP. It would be pair. I will start from I equal to n minus 1 to 0, I minus minus. As I said earlier, L will go from, for L we require L plus 1. So we would go in descending order, and for the right one we require R minus 1. So we will go in ascending order. Okay, now the DPI of X would be, if we take the ith index, that is d of I plus dp of I plus 1 j dot second. Long y is p of j plus dp of dot second. So see, we are going j, we would require j minus 1, which would be always calculated, and here also we would require I plus 1, which would be always calculated. Okay, we can add a condition if I equal to j, then dp of I comma j is simply the value itself and 0. So now it will avoid us. So okay guys, now if X is greater than Y, we would go with first opportunity. So dp of I comma j would be X and dp of I plus 1 j dot first. Or dp of I comma j would be Y comma dp of I j minus 1 dot first. Okay, and at last we would output dp of 0 comma n minus 1. Okay, so this would run. So else what happened? Okay, sorry, dot first. Okay, so we got our answer. Let's submit it. Okay, so it got accepted. Okay, so I hope you got it. Okay, so guys, see you in the next video. These type of problems are a bit difficult to, I would not say difficult to tackle. I mean, you the only way to get better in DP is you just have to practice and practice a lot. Like to go from first we have to go from writing the recursion to directly writing the tabular one. You would you should have you should have practiced a lot to get from here to get from recursion to direct tabular one. Okay, so it's as I used to say, it's all about visualization. Okay, here also how L is working, how R is working. So what are the values which we have to calculate first? Which are the values which we can calculate later? That all depends on how you think about the problem. Okay, so I would say practice as many problems as you can and see you in the next video.